Good morning to all of you. Today we shall start with your new chapter, that is surface chemistry. Surface chemistry, it is a branch of chemistry which deals with the phenomena taking place on the surface. There are certain terms which you must clear. First is adsorption. First term is adsorption. It is the phenomena of retaining the molecule on the surface of the solid. It consists of adsorbate and adsorbent. Adsorbate is a substance which is being adsorbed on the surface, and the substance on which it is adsorbed, that is called adsorbent. Adsorption can be classified as positive adsorption and negative adsorption. Positive adsorption is the retaining of the molecules on its surface more than on the bulk. For example, concentrated solution of KCl shaken with blood charcoal. Now come to negative adsorption. It is the retaining of molecules more on the bulk than on its surface. For example, dilute solution of KCl shaken with blood charcoal. Student, next comes out to the topic how the absorption differs from adsorption. Absorption is a bulk phenomena, whereas adsorption, it is a surface phenomena. In absorption, there is a uniform concentration of the species throughout, but in adsorption, the concentration of the species on the surface and the bulk is different. Absorption is endothermic process, whereas adsorption, it is exothermic process. In absorption, the rate remains same throughout the process, but in adsorption, the rate is higher in the beginning and then decreases till the equilibrium is achieved. Occlusion is the adsorption of gases on the surface of metals. Absorption is a phenomena when both adsorption and absorption takes place simultaneously, for example, dyes. There is also a term desorption. It is the phenomena of removal of adsorbate from the surface of adsorbent. It can be achieved either by increasing the temperature or by decreasing the pressure. Now students, come to the next topic, that is mechanism of adsorption. If we consider a liquid, there are two types of molecules in it. The molecule which is present in the bulk experience equal and opposite forces from all the sides. So, the net force on it is 0. But the molecule which is present on the surface experience inward pull of attraction, which cause surface tension. Because of the unbalanced inward forces of attraction or free valences at the surface, liquids and solids have the property to attract and retain the molecules of a gas or a dissolved substance onto their surface with which they come in contact. Now students, the adsorption, it is an exothermic process. What is the reason for it? Actually, whenever the adsorption takes place, the residual forces on the surface of the adsorbent decreases. This appears in the form of heat called heat of adsorption, hence it is exothermic. Now, the entropy change whenever the adsorption takes place is negative. So, for the adsorption to take place, delta G must be negative. We know that delta G equal to delta H minus T delta S. For delta G to be negative, delta H must also be negative. Hence, whenever the adsorption takes place, all the terms, that is entropy, Gibbs free energy and delta H, all are negative. Now students, next topic is factors affecting adsorption. First factor is surface area of the adsorbent. Greater the surface area of adsorbent, faster will be the rate of adsorption. That's why the charcoal and silica gel are considered as excellent adsorbent. Second factor is nature of the gas being adsorbed. Different gases are adsorbed to different extent by the same adsorbent at the same temperature. It depends upon the critical temperature of the gas. Greater the critical temperature of the gas, faster will be its rate of adsorption. Third factor is temperature. Adsorption, it is an equilibrium process involving two opposing processes, condensation and evaporation. This equilibrium is exothermic in nature. When we will increase the temperature of this equilibrium according to Le-Chatelier principle, the equilibrium will shift in the backward direction. Last factor is the pressure. With increase in pressure, the rate of adsorption increases. Now students, your next topic is activation of solid adsorbent. It means increasing the adsorbing power of an adsorbent. It can be achieved either by making the surface area of the adsorbent rough or by removing the gases already adsorbed, and third is by increasing the surface area of adsorbent. Well, come to the next topic, that is types of adsorption. There are two main types of adsorption: physical adsorption and chemical adsorption. Physical adsorption, it occurs when the gas is held on the surface of the solid through weak van der Waals forces, whereas chemical adsorption occurs when a gas is held to the surface of the solid through a strong chemical bond. Now there are certain differences between physical and chemical adsorption. First difference is the force operating in the physical adsorptions are weak van der Waals forces, where in chemical adsorption this is a strong chemical bond. Second difference, the heat of adsorption in physical is 20 to 40 kilojoule per mole, but in chemisorption it is 40 to 400 kilojoule per mole. Third difference is the physical adsorption is reversible, while the chemical adsorption is irreversible. Next difference is physical adsorption does not require any activation energy, whereas chemical adsorption requires activation energy. Next, physical adsorption occurs at low temperature and decreases with increase in temperature, while chemical adsorption first increases with increase in temperature and then decreases. Next is the physical adsorption is not specific, whereas chemisorption it is specific in nature. Physical adsorption forms multimolecular layer, whereas chemisorption forms unimolecular layer. Physical adsorption increases with increase in surface area of adsorbent, whereas chemisorption also increases with increase in surface area of adsorbent. Now come to the next topic, that is adsorption isotherm or Freundlich adsorption isotherm. Adsorption isotherm, it is a graph between the amount of the gas adsorbed per gram of the adsorbent, that is X over m, and that of equilibrium pressure of the adsorbate at constant temperature is known as adsorption isotherm. Now come to the graph. Now look at the graph. It is plotted between the rate of adsorption with respect to the pressure, keeping the temperature constant. There is the term saturation pressure. What is that? At a value of saturation pressure, X over m, that is the rate of adsorption, reaches its maximum value and then it remains constant even though the pressure is increased. This is the saturation state and PS is the saturation pressure. Now students, in this graph it is clear that at low value of pressure the graph is nearly straight. Hence X over m equal to Kp. At high pressure, X over m is independent of pressure, that is X over m equal to Kp naught, and in the intermediate range of pressure, X over m equal to Kp 1 over n, where n is a positive integer, n and k are constant. Now we know that X over m equal to Kp 1 over n is known as Freundlich adsorption isotherm. Now what is the limitation of Freundlich adsorption isotherm? This relation holds good over a limited range of pressure. Now students, we come to the validity for the Freundlich adsorption isotherm. as we know that x over m equal to kp 1 over n. To test the validity of this equation, taking logarithms of both sides of this equation, we will get the result log x over m equal to log k plus 1 over n log p. A graph, when plotted between log x over m against log p, it will give a straight line with slope equal to 1 over n and intercept equal to log k. After adsorption isotherm, come to the adsorption isobar. It is a graph plotted between the amount of the gas adsorbed with respect to the temperature, keeping the pressure constant. Now students, from the graph, it is clear that for physical adsorption, the rate of adsorption decreases with increase in the temperature. It is clear to all of you. But when we look at the chemical adsorption, first it increases and then it decreases. The initial increase is because of the fact that the heat supplied act as activation energy. So students, we have discussed all the topics come under this adsorption. Now last is your applications where the process adsorption can be used. Its first application is in gas masks. All the gas masks are the devices containing suitable adsorbent so that the poisonous gases present in the atmosphere are preferentially adsorbed and the air for breathing is purified. Second application is in froth flotation process. When sulfite ore is shaken with pine oil and water, the ore particles are adsorbed on the froth that floats and the gangue particles settle down in the tank. This method is known as froth flotation process for the concentration of sulfite ore. Its third application is in removing the moisture from air in the storage of delicate instruments. Fourth application is in the softening of hard water. Then next application is in chromatography analysis. The selective adsorption of certain substances from a solution by a particular solid adsorbent has helped to develop a technique for the separation of the components of the mixture. This technique is called chromatographic analysis. Next application is in the clarification of sugar. Sugar is decolorized by treating sugar solution with charcoal powder. The latter adsorbs the undesirable colors present. So these are the applications. Thank you.